Hello guys, so Sonal Palve here, and now we are going to discuss the time complexity and space complexity. So basically in data structures consist of algorithms, and certain algorithms need to be analyzed. So for that, these two concepts are taken in consideration, that is time complexity and space complexity. So at the very first, we will discuss about time complexity. So what is time complexity? Time complexity is a function describing the amount of time an algorithm takes in terms of the amount of input to the algorithm. Let's take an example on time complexity to understand it in a better way. So for an example, if a boy wants to take some PDF files from his friend, then he has two ways. Let's assume that boy will have two ways to be adopted to take PDF files from his friend. The first way is he could either tell to his friend to send those files in online mode. So what his friend will do, he will either send it through email ID, or he will upload it on Google Drive, or he can either WhatsApp to him, right? Or else the second way is that he will decide to visit his friend physically, and he can take those PDF files in pen drive also. So here majorly two ways are available to him. So accordingly, what he will do is he will decide which way is to be adopted on the basis of time taken by the algorithm to be executed. This is, let's say this is first algorithm which is available to him, and this is the second algorithm which is available to him to take PDF files from his friend. So based on these two conditions, he will consider the time taken by these two algorithms, and by considering the size of input. Let's say if the PDF files is of 250 KB, is of size 250 KB, so he can easily tell to his friend to send it through online mode. Okay, let's assume that your daily data is 1 GB. Fine. So you are having 1 GB data, and in 1 GB data you are going to receive those files. So file size is 250 KB, so it will be easy to receive it, right, in online mode. So there is no need of visiting him physical. And but let's say the file size is 30 GB. Now the file size itself is 30 GB, and your mobile data is 1 GB per day. So I think it is difficult what it is impossible to take those files, right, in online mode. So what that guy has to do is he have to go and he have to physically visit the friend, and he have to take it in pen drive. That's only the way he have to he will be going to deal with, right? So what I am going to tell you that he has considered these both situations, that the file will be 250 KB. That is, first he considered the size of input, right? So if the size of input is 250 KB, so he is going to adopt this way. But if the size of input is 30 GB, then he is going to adopt this way. But he will also consider the time taken by algorithm. Why he decided to take those files in online mode when it was 250 KB size of files? Because it was the fast process, and the time required to do such process was less. But when he considered 30 GB of files, which he wants to take in 1 GB data, it sounds very, very typical that taking 30 GB of files in 1 GB data is almost impossible. So he adopted the second way. Likewise only we have to consider these two situations in analysis of algorithm 2. We have to first consider the time taken by algorithm, and then size of input which we are going to deal into that algorithm. Now the question comes that how do we measure time complexity? So it is basically measured by considering three cases. The first case is best case. Here the input set allows to an algorithm to perform quickly and it takes shortest time to execute. The next one is the worst case. Here the input allows to an algorithm to perform more slowly and it takes longest time. And the average case. Here the input set allows to an algorithm to deliver average performance. So these are three cases which are considered to measure the time complexity. And for example, right now we have taken the example of that boy which wants to take some files from his friend. At that time, when the file size was 250 KB, right? The file was, one second, I will write here. This file size was 250 KB. So at that time, he was able to receive those files in 1 GB of data, right? Because 250 KB size was compatible with 1 GB of data. It was easy to receive it and it was also quick to perform. Am I correct? That is called as best case. But when it comes to 30 GB of files receiving in 1 GB of data, it was literally hectic. It was really impossible to receive these 30 GB of files in 1 GB of data. And this input size was allowing to an algorithm to perform more slowly. So this is the best case and worst case, and this is how it works. It first takes in consideration the input set, the size of input set, and then it allows an algorithm to perform either quickly or either slowly. And on that basis, it is decided whether it is a best case or it is a worst case. And what is average case? Suppose the file size is not 250 KB and not 330 GB now. The file size is 1 GB right now, and then you know that 1 GB of file, receiving 1 GB of file in 1 GB of data will give an average performance. It will not be either slow or either fast process. It will be an average process. So it will take constant time to receive the 1 GB of file in 1 GB of data. This is how best case, worst case, and average case is defined actually. Now, time complexity is always measured using asymptotic notation. So, what are asymptotic notations? Asymptotic notations are the mathematical notations used to describe the running time of an algorithm when the input tends towards a particular value or limiting value. Like this was the input which was tending to at the first at 250 KB, then 30 GB, then 1 GB. This was the input. Okay. And what was the running time of an algorithm? Running time of an algorithm was a time taken to perform a certain kind of algorithm. So at the very first, we will focus on best case. Here is the graph of best case and the condition for the best case. So let's see. There are two functions present over there. One is f of n and the another is g of n. F of n is the upper bound and g of n is the lower bound. And here is the condition for the best case that the lower bound, that is g of n, is always less than equals to c dot fn. Here c is the constant term, whereas f of n is the upper bound and the g of n is the lower bound. So what we are going to do is, we will see one example first. Here omega of f of n equals to 3n plus 2 means one function is given 3n plus 2. This is the value of f of n. Okay, this is the value of f of n. And what do this omega of f of n represents? That omega of f of n represents that we are calculating the best case. So for considering whether it is a best case or not, what you have to do is you have to search out for such a value of g of n where this condition satisfies. Which condition? G of n is less than equals to c dot fn. So what I did is I compared these two equations. What is f of n? F of n is 3n plus 2. So I took 3n plus 2. Now f of n is greater than equals to g of n. So it is greater than equals to g of n. Now here g of n I placed as 3n. Why 3n? Because 3n is satisfying this equation of best case. How? I checked it through inputting each integer into it. For example, n equals to 1. As soon as I put 1 into it, so 3 into 1 is 3. 3 into 1 is 3 plus 2 is 5. So 5 is greater than equals to 3. It means that it is satisfying the equation. So hence we found g of n, and g of n is 3n, whereas for all n greater than equals to 1, right? Why greater than equals to 1? Because it is satisfying for 1 also. This equation is satisfying for 1 also, but also it is for the sure. If it is satisfying for 1, then it must be satisfying for all the values which are greater than 1. So this is how the best case is calculated. Now let's move ahead and focus on the worst case. So worst case, here is the graph and here is the condition of the worst case. So here the upper bound is g of n and the lower bound is f of n. So in the worst case, what is the condition? The condition is totally opposite of the best case. In best case, f of n was greater than equal to g of n. C dot was greater than equals to g of n. Now here the g of n is greater than equals to f of n, which is totally opposite. So let's take an example on it. We are calculating worst case, hence big O of fn is taken in consideration. Now f of n is again 3n plus 2. Now we have to find the value of g of n, such a value of g of n which satisfies the equation, this equation. So let's replace the f of n by 3n plus 2 is less than equals to, now I took g of n as 4n. Now let's test for which values of n this condition is satisfying. So first we will take 1. 4 into 1, 4. Now here 4 into 1, sorry, 3 into 1 is 3 plus 2 is 5. So 5 is less than equals to 4. Is it true? No. So for n equals to 1, it is not satisfying. Let's take another value, that is 2. 4 2s are 8. 3 2s are 6. 6 plus 2 is 8. So 8 is less than equals to 8. Is this condition satisfying? Right. This condition is satisfying. Means the equation 3n plus 2 is less than equals to 4n is satisfying for all n greater than equals to 2. And hence we solved the equation and we found the worst case. Now let's have a look on average case. So in average case, this is the graph and this is the condition. So here, when the average cases arise, actually when the algorithm isn't performing quickly and neither it is performing slowly, so at that time the average case is taken in consideration. Means the algorithm is giving average performance at that time. So what is the condition for average case? Here g of n is completely equal to the big O of f of n, and also g of n is completely equal to the omega of f of n. So here big O of f of n means what? Worst case of f of n. And what is omega of f of n? Means best case of f of n. So g of n is equal to both of the conditions here. Let's take an example. As we are calculating average case, so we are using the theta of f of n, which is equal to 3n plus 2. Now you know that both conditions are satisfied here, means g of n is equal to big O of fn also, and g of n is also equals to omega of f of n. So you could neglect my handwriting here actually. I'll write it. Yeah. So then you could represent it as 3n plus 2 is less than equals to 4n for all n greater than equals to 2. Right now we have seen, and 3n plus 2 is greater than equals to 3n for all n greater than equal to 1. So here in the average case, what is Gn? Gn could be either 4n or 3n because both conditions are getting satisfied over in average case. So this is how the average case, best case and worst case is calculated. Now let's have a look on these examples of having some worst case in different kinds. So the first one is big O of 1, that is constant, log n as logarithmic, big O of n as linear, big O of n log n as linear arithmetic, n square as quadratic, n cube as cubic, 2 raised to n as exponential, and n factorial as factorial. And these are some examples which are having those worst case respectively. Actually, I'm not going to discuss this in much detail. You could go through it as I'm providing all these tables and all, and my PPT is over there in resources link, so you could go there and could download them. So let's move ahead, and this is how the chart of big O complexity is. Here, whenever the worst case is defined as big O of log n and big O of 1, then you could say that that algorithm is running in excellent way. Okay, that algorithm is running in a very excellent way because there are less worst case there, and when it is big O of n, then you could see here that it is given as a fair, and when it is big O of n log n, then it is very bad, and obviously at these stages it is very horrible. So you could go through this also further on. Now we will discuss about the space complexity. So what is space complexity? It is a measure of the amount of working storage of an algorithm needs. Means it is the amount of storage which is needed by algorithm. So for example, we will consider the before example which we have took of the boy which wants to collect his old files with his friend. So before going through example, what I am going to do is I will like to tell you that space complexity includes both. One is auxiliary space and the another is space used by input. So what is auxiliary space? Auxiliary space is the space which is variable, means the space which is varying time to time, whereas the space used by input is fixed space. So space complexity is addition of both, which is fixed space requirement and the variable space required. Now let's focus on the space required. This calculation is how much data used plus size of file. Actually, I'm taking this in consideration with respect to this example. Okay, so this is not the actual process. Okay, we are just taking in consideration this example, and according to it we are calculating the space required. So we have considered that there were two kind of files. One was of 250 KB and the another was of 30 GB, and accordingly we selected the algorithm which we are going to perform. So at the first, when it was 250 KB, that boy told to his friend that he could download that file, that 250 KB size of file easily, so he could receive it online, in online mode. And when it was 30 GB, so the boy adopted to perform the algorithm of physical visit, right? That boy was going to visit him physically, and then he was collecting that files through pen drive or through PD. likewise. So what actually is going to help here is when it was 250 kb, the file size was 250 kb, how much data was used? It might be less than 1 GB or equal to 1 GB, but it would not be more than 1 GB, right? Because the size of file is very low, that is very less. It is just 250 kb, so it could be downloaded within the 1 GB also. But when it comes to 30 GB, more than 1 GB was required, right? So have look on this 1 GB and more than 1 GB. You could consider it as auxiliary space. And the another one is 250 kb and 30 GB. It could be considered as the space used by input. Why it is auxiliary space? Because you know that you are getting per day 1 GB data. So if it happens that today my 1 GB data is now finished, so it is again getting upgraded on next day, and again you are getting 1 GB data, right? Because you have subscribed to such a pack which is giving 1 GB data per day. Means this is the auxiliary space. It is varying time to time. Whereas the size of file, once you downloaded 250 kb of file, it is going to occupy the 250 kb of space within your mobile phone, within your memory of the mobile phone. Am I correct? And when it is you are going to download the 30 GB size of file, so again same thing is happening, nothing is changing. That much amount of space will be occupied by those 30 GB of files. Means it is not varying. That's why it is called as fixed space, which is space used by input. Hope you got how the space complexity is and how the space required is calculated. Let's move further. Now, how the space complexity actually works, we are going to see that, because that was just a daily life based example. Now we are going to see how actually it is calculated. So space complexity of an algorithm represents the amount of memory space needed the algorithm in its life cycle. Just now we have discussed that only. So space needed by an algorithm is equal to the sum of two following components. Which components? I just tell you. It is one fixed space required and variable space required. So it could be represented like this. Space complexity equals to the addition of the two components. One is the fixed space required and the another one is variable space required. So a fixed part. Which part in the algorithm could be called as fixed part? Simple variables and constants, program size, etc. could be called as fixed part. So a fixed part, that is a space required to store certain data, and variables, that is very simple variables, constant, program size, etc. that are not dependent of the size of the problem. Those are called as fixed part. And what is the variable part? It is the space required by variables whose size is totally dependent on the size of the problem. For example, recursion, stack, then dynamic memory allocation, etc. Right? Now we are going to see the space complexity of simple arithmetic function. So have a look on this example. So here what we are going to do is we have created one float ABC function where the parameters are passed such as float A, float B and float C, and what that function is going to return, it is returning certain kind of operations done on data, and it is returning the calculation of this whole operations. Now what is space complexity of simple arithmetic function here? It is C plus S of ABC I. Means it is the addition of the fixed space required and the variable space required. As you can see, once the parameter is passed, means the values are passed through parameter, and it is returning the answer of the certain kinds of operation done on them. It is calculating this and it is returning this. So here it will be having only the fixed space requirement. Why? Because you can see once the value entered, once the values which are accepted through these parameters are stored somewhere, and it is not going to change at any instance. It is not depend on the size of program. That's why here the space complexity will be only C, means C plus 0. So space complexity will only be the fixed space requirement, and it is having only fixed space requirement. This is the conclusion of the whole program. So this is how the space requirements is space complexity of a simple arithmetic function is calculated over here. Now we are going to see the space complexity of iterative function. So here we will take one example. One second, let me pick pen first. Yeah. So here we created one function whose name is sum. So float sum is having two parameters. The first parameter is float array whose name is list, and the another one is the int n. The another one is one integer value whose name itself is n. Now, what actually happening here? At the first, we initialize one float variable, that is temp sum, to 0. Then we have taken one more integer variable, that is I. We set the for loop, and in for loop what is going to be held over there, that it is calculating the addition of each element present over in the array, and it is returning the addition of each element present over there. So let's take an example. For example, 3, 4, 7 and 8. These are some elements which are stored into this array, and we are going to calculate the addition of these 4 elements. So how it will be done? First, temp sum is initialized to 0. Now list of I equals to 0. 0 is less than 4, true. So what will be the list of 0? List of 0 will be the first element present over there. So it is 3. So 0 plus 3 is 3. Return 3. It will return 3. Again, now this loop is going to run. Okay. This loop is going to run until it reaches to 8. So 3 plus 4, next it will retrieve 4 from it. Now 3 plus 4 is 7. Now again it will return 7. Now 7 plus 7 is, what is 7 plus 7? 7 plus 7 is 14. Now again it will return 14. 14 plus 8 is, what will be the 14 plus 8? 6. Yeah. So it will be 22. It will return 22 to us. Right? So for this sure, what is happening here is the input was an array. Right? Float list means it is an array, but the output is simple value. So here variable space requirement depends on how the array is passed into the function. That is, there is one language called Pascal, where Pascal passes array by values. Means it what it actually do, it entire array is copied into the temporary storage before the function is executed in Pascal language. Whereas in C passes all parameters by value. Like we pass values here through parameters only, right? And when the array is passed as an argument to a function, C interprets it as passing the first element of the array. Means in Pascal, in language like Pascal, the entire elements are first copied into temporary storage and then it is used. But it doesn't happen in C. C actually passes all parameters by values. Means whenever 3 is needed, it was retrieved. Then 4 is retrieved. Then 7. Then 8. It is passing all values by parameters. This is the way which includes the calculation of space complexity over here. So C does not copy the array. It actually passes those arrays only which were first passed by the parameters. Hence, the space complexity of iterative function is 0. This is the conclusion of this whole program, right? Now we are going to discuss about the space complexity of recursive function. So here is one example. What we are going to do here, we created one function that is float rsum, which is again taking two parameter. One is the array and another one is simple integer variable. So we are taking one condition that if n, return the rsum of list comma n minus 1 plus list of n minus 1. Means here what is actually happening, the space needed for one recursive call is the number of bytes required for two parameters and the address. What it actually means, whenever you are calling, means for one recursive call of this function float rsum, what will be the space needed? Space needed would be the number of bytes of which these two parameters are taking, and also the return address, because this output is going to store at some address, and by default that address is having 4 bytes of memory. So float list, let me show you this. Yeah. So here first parameter is array. How much bytes of array is taking? It is of float data type, so obviously it is taking 4 bytes. Now int n, it is having integer data type, so it will also take 4 bytes. The next one is the address, and right now I said that array by default always takes 4 bytes. So how much bytes of memory is needed for one recursive call is 12 bytes. 4 into 3, that is 12 bytes. This is how the space complexity of recursive function is calculated. Just you have to calculate the number of bytes taken by the parameters which have been passed through that function, and also the address which is going to return. So here, if array has n equals to maximum size, means the size of this n will be the max size. So at that time, what will be the space needed for the recursive function is, it will be the 12 into max size. For example, max size is 1000. Okay, max size is 1000. So at that time, the space needed for that recursive function would be 12 into 1000, that is 12,000 bytes. This is how the space complexity of recursive function is calculated. If you want one more example, you could take it as, if the max size is 2000, then it will obviously return the 24,000 bytes, right? So this is how the space complexity of recursive function is going to be calculated, and hope you understand how iterative and recursive function works and how the space complexities of those functions are calculated. So hey guys, thank you so much. I'll see you in the next class.